The air inside tastes like 1,000 flavors colliding at once. Sweet, tart, fruity, chemical precision mixed with culinary chaos. This is where science meets candy, where industrial engineering transforms simple sugar into one of the world's most beloved confections. Behind these factory walls, machines operate with surgical precision, churning out millions of tiny, glossy beans every single day. Most people pop a jelly bean into their mouth without a second thought, never questioning the intricate ballet of technology that brought it to life. But what if I told you that creating a single jelly bean requires more steps than assembling a smartphone? That the process takes anywhere from 7 to 21 days? That some factories use technology originally developed for pharmaceutical manufacturing? Welcome to the hidden world of industrial candy production, where ancient confectionery traditions collide with cutting-edge automation, where flavor chemists work like perfumers, and where quality control operates at microscopic levels. This isn't your grandmother's candy kitchen. This is a high-tech jelly bean factory, and what happens inside will change how you see these colorful little gems forever. The machines never sleep. The conveyor belts never stop. And the secrets you're about to discover have been closely guarded by manufacturers for decades. Step inside. The jelly bean industry generates over $400 million annually in the United States alone, with more than 16 billion beans produced each year. That's enough to circle the Earth nearly 5 times if laid end to end. But here's what most people don't know. The modern jelly bean bears almost no resemblance to its 19th century ancestor. The original jelly beans were Turkish delight candies that American confectioners modified during the Civil War era, sending them to soldiers as morale boosters because they were durable and didn't melt. Fast forward to today, and we are looking at flavor profiles that include everything from buttered popcorn to jalapeno, from draft beer to roasted marshmallow. Some premium manufacturers offer over 100 distinct flavors, each requiring its own precise chemical formula. The flavor creation process alone is mind-bending. Flavor chemists, often called flavorists, spend years training their palates to identify and recreate tastes at the molecular level. They work in laboratories that look more like something from a pharmaceutical company than a candy factory, using gas chromatography and mass spectrometry to analyze flavor compounds. When creating a new jelly bean flavor like toasted coconut or cappuccino, they might combine anywhere from 20 to 80 different chemical compounds. These aren't artificial in the scary sense. Many come from natural sources, but they're isolated, concentrated, and recombined in ways that would never occur in nature. A single strawberry jelly bean might contain flavor molecules extracted from actual strawberries, combined with esters that enhance sweetness perception, aldehydes that provide fruity notes, and lactones that add creaminess. The result? A flavor more intensely strawberry than an actual strawberry. Here's something that will blow your mind. Premium jelly bean manufacturers use a process called flavor layering, where different taste compounds are added at different stages of production. The center might have one flavor profile, the shell another, and the final coating yet another. This creates what food scientists call flavor evolution. The taste literally changes as you chew. That's why a gourmet jelly bean tastes different after 5 seconds in your mouth than it did initially. This technique was borrowed from the wine and spirits industry, where master blenders have used similar concepts for centuries. The texture engineering is equally sophisticated. That perfect chew, not too hard, not too soft, with just the right amount of resistance before yielding, requires precise control of moisture content, sugar crystallization, and pectin or starch gel formation. Food engineers spend months calibrating these variables. Too much moisture and the beans become sticky and clump together. Too little and they turn rock hard. The target moisture content typically hovers around 20 to 22%, maintained through every stage of production with obsessive precision. Some factories use humidity-controlled rooms where the air itself is engineered to prevent moisture loss or gain during the manufacturing process. Color technology in jelly bean production has evolved dramatically. While early jelly beans used coal tar dyes that would horrify modern consumers, today's manufacturers employ either FDA-approved synthetic colors or natural alternatives derived from plants, minerals, and insects. Yes, insects. That beautiful red color in some jelly beans? It might come from cochineal extract, made from crushed cochineal bugs. The iridescent shimmer on some premium beans comes from confectioner's glaze, which is actually secreted by the lac bug. These natural options cost significantly more than synthetic dyes, sometimes 10 to 20 times more, which is why premium jelly beans command higher prices. The color must also remain stable through temperature fluctuations, exposure to light, and the acidic environment created by certain flavors. Achieving this stability requires sophisticated chemistry. Here's a fascinating industrial secret. Many high-tech jelly bean factories operate on what's called a continuous production model, meaning the manufacturing line literally never stops. Machines run 24 hours a day, 7 days a week, with maintenance performed on rotating sections while others keep producing. This is necessary because stopping and restarting certain processes, particularly the sugar cooking and coating operations, would waste enormous amounts of product and energy. Some factories have been running continuously for years, with only brief shutdowns for deep cleaning or major equipment upgrades. The logistics of this are staggering. Ingredient deliveries arrive on precise schedules. Worker shifts overlap to ensure seamless transitions. Computer systems monitor thousands of variables in real time, making micro-adjustments to temperature, humidity, mixing speeds, and coating thickness dozens of times per second. The quality control technology would impress any tech enthusiast. Modern jelly bean factories employ machine vision systems that photograph every single bean as it passes on the conveyor belt. These cameras, operating at incredible speeds, can detect color variations, size discrepancies, surface defects, and foreign objects smaller than a grain of sand. Beans that don't meet specifications are ejected by precision air jets in milliseconds. Some facilities also use X-ray inspection systems originally developed for airport security to detect internal defects or foreign materials that cameras can't see. The rejection rate in premium facilities can be as high as 5 to 8%. Millions of beans that never make it to the bag because they're slightly off color or fractionally misshapen. Let's talk about the environmental footprint, because it's surprisingly complex. A single jelly bean requires approximately 0.03 gallons of water to produce when you account for ingredient processing, equipment cleaning, and cooling systems. Multiply that by 16 billion beans annually, and you're looking at nearly 500 million gallons of water just for US jelly bean production. Progressive manufacturers have implemented closed-loop water recycling systems that recapture and purify up to 70% of water used in production. Energy consumption is equally significant. The sugar cooking process alone requires sustained temperatures of 300 degrees Fahrenheit, while the coating rooms must maintain precise climate control. Some factories have installed cogeneration systems that capture waste heat from cooking operations to warm other parts of the facility or generate electricity, improving overall energy efficiency by up to 30%. Raw materials arrive at the factory in industrial quantities that seem almost absurd. Sugar arrives in 50,000-pound tanker trucks. Corn syrup comes in railroad tank cars holding 80,000 pounds. Flavor concentrates, despite their potency, are delivered in drums containing hundreds of gallons. The receiving area of a major jelly bean factory resembles a logistics hub more than a food facility, with forklifts moving pallets, automated storage and retrieval systems tracking inventory, and quality control technicians testing samples from every delivery. Each ingredient batch receives a unique tracking code that follows it through the entire manufacturing process, allowing complete traceability. If a quality issue arises weeks later, manufacturers can identify the exact sugar shipment, corn syrup batch, and flavor lot that went into those specific beans. The manufacturing process begins in the cooking room, where industrial kettles, some holding over 1,000 pounds of mixture, combine sugar, corn syrup, water, and other ingredients. These aren't your kitchen pots. They're precision-engineered vessels with computerized temperature control, automated stirring mechanisms, and vacuum systems that can reduce internal pressure to lower boiling points and prevent caramelization. The mixture is cooked to exact specifications, typically reaching temperatures between 290 and 310 degrees Fahrenheit. Timing is critical. 30 seconds too long and the batch develops off flavors. 30 seconds too short and the texture will be wrong. Sensors monitor viscosity, temperature, and sugar concentration continuously, feeding data to control systems that adjust heat input in real time. Once cooked to perfection, the hot syrup is pumped to depositing machines or molding systems. In traditional operations, the mixture is poured into starch molds, trays filled with cornstarch that have been stamped with thousands of bean-shaped impressions. The hot liquid fills these impressions and cools into the characteristic jelly bean shape. Modern high-tech facilities increasingly use mogul systems, which are automated starch molding machines that can produce up to 4,000 impressions per minute. These machines create the molds, deposit the mixture, allow it to set, then extract the form centers and recycle the starch in one continuous operation. The precision is remarkable. Each center must be within 0.01 grams of target weight. After molding, the centers spend anywhere from 24 to 48 hours in conditioning rooms where temperature and humidity are carefully controlled to allow proper crystallization and moisture equilibration. This is where the magic of texture development happens. The starch or pectin gel structure sets up, creating that distinctive jelly bean chew. Rush this process and you get beans that are too soft or that weak moisture. The conditioning rooms are typically kept at 65 to 70 degrees Fahrenheit with relative humidity around 50 to 60%. Some facilities use forced air circulation systems that gently move air around the beans to ensure even drying without forming a hard crust. Then comes the coating process, which is where jelly beans truly come to life. The centers are loaded into massive rotating drums called panning drums or coating pans. These industrial giants can hold hundreds of pounds of beans and rotate continuously while thin layers of sugar syrup are applied. This is called soft panning, and it's an art as much as a science. Each coating layer must be applied at precisely the right thickness. Too thick and it cracks, too thin and it doesn't build up properly. Between each layer, the beans must dry completely, which is achieved by blowing temperature-controlled air through the rotating drum. A typical jelly bean receives anywhere from 20 to 40 separate coating layers over the course of several days. Each layer adds color, smoothness, and that glossy shell that makes jelly beans so visually appealing. The color is usually added during the coating process, mixed into the sugar syrup. This requires extraordinary precision because the final color must match the flavor. Consumers have strong expectations. Yellow should taste like lemon, red like cherry, green like lime. Deviating from these expectations confuses the palate and reduces enjoyment. The color mixing systems use computer-controlled dispensers that add dye in amounts measured to the hundredth of a gram, ensuring batch-to-batch consistency. Some premium manufacturers apply multiple color layers to create depth and visual complexity. The final coating stage involves polishing, where the beans are tumbled with confectioner's glaze, carnauba wax, or beeswax to create that signature shine. This step also seals the surface, preventing moisture loss and extending shelf life. The polishing drums rotate at specific speeds. Too fast and the beans chip against each other, too slow and the coating doesn't distribute evenly. The entire coating process, from bare center to finished bean, typically takes 7 to 14 days for standard jelly beans, and up to 21 days for premium varieties. Quality control intensifies as beans approach completion. Samples are pulled regularly for sensory evaluation by trained taste panels. These aren't casual candy tasters. They're professionals who have calibrated their palates through extensive training. They evaluate flavor intensity, flavor accuracy, texture, coating integrity, and overall quality against established standards. Chemical analysis confirms sugar content, moisture levels, and the absence of contaminants. Microbiological testing ensures the product is safe for consumption. Only after passing all these checkpoints do the beans move to packaging. The packaging area is a marvel of automation. High-speed weighing and bagging machines can package thousands of bags per hour, with each bag weighed to ensure it contains the correct amount. Metal detectors scan every package to catch any foreign objects that might have entered during production. Bags are coded with production dates and batch numbers, then packed into cases, palletized, and wrapped for shipping. The entire process from finished bean to packaged product can take less than an hour in highly automated facilities. Robotics have revolutionized jelly bean manufacturing in recent years. Automated guided vehicles transport materials between production areas. Robotic arms handle repetitive tasks like loading and unloading panning drums. Collaborative robots work alongside human operators in packaging, handling tasks that require precision but not decision-making. Some cutting-edge facilities have implemented artificial intelligence systems that analyze production data to predict equipment failures before they happen, schedule preventive maintenance, and optimize production parameters for maximum efficiency and quality. These systems learn from millions of data points, identifying patterns that human operators might miss. The logistics of flavor variety are particularly challenging. A facility producing 100 different flavors must manage 100 different flavor formulas, color combinations, and production schedules. Cross-contamination between flavors is a constant concern. Equipment must be thoroughly cleaned between flavor runs, which can take hours and generate significant waste. Some manufacturers have dedicated production lines for specific flavor families to minimize changeover time. Others use sophisticated scheduling algorithms that sequence production runs to minimize cleaning requirements, running similar flavors consecutively, for example, or progressing from lighter to darker colors. Safety and sanitation standards in modern jelly bean factories rival those in pharmaceutical manufacturing. Workers wear hairnets, beard nets, gloves, and cleanroom garments. Facilities maintain positive air pressure to prevent outside contaminants from entering. Surfaces are made from stainless steel or food-grade plastics that can withstand aggressive cleaning chemicals and high-temperature sanitization. Cleaning protocols are documented and verified, with ATP bioluminescence testing used to confirm that surfaces are truly clean at the molecular level. Allergen control is particularly critical, as many facilities also produce products containing nuts, dairy, or other common allergens. Dedicated allergen-free production lines, rigorous cleaning validation, and careful ingredient segregation help prevent cross-contact. The future of jelly bean manufacturing is heading toward even greater customization and technology integration. Some companies are experimenting with three-dimensional printing technology to create custom shapes and flavor combinations on demand. Others are exploring natural flavor extraction techniques that use supercritical carbon dioxide instead of chemical solvents, producing cleaner, more authentic flavors. Sustainability initiatives are driving innovations in packaging, with manufacturers testing compostable films and recycled materials. There's even research into using artificial intelligence to create entirely new flavor combinations by analyzing consumer preference data and predicting which novel flavors might succeed in the market. The jelly bean industry continues to evolve, blending traditional candy-making craftsmanship with space-age technology. What started as a simple confection for Civil War soldiers has become a showcase for food science, engineering precision, and manufacturing excellence. Every colorful little bin represents the culmination of centuries of confectionery knowledge and decades of industrial innovation. But jelly beans aren't the only classic treat getting the high-tech treatment. While these tiny candies showcase precision manufacturing at microscopic scale, there's another beloved dessert that's being revolutionized by modern factory automation, one that combines fruit, pastry, and nostalgia in equal measure. The video that just appeared on your screen takes you inside a modern apple pie factory, where industrial ovens bake thousands of pies daily, and robotic systems create lattice crusts with mathematical precision. If you thought jelly bean production was impressive, wait until you see how technology has transformed one of America's most iconic desserts. Click that video now and discover the surprising science behind factory-made apple pies. Before you go, I want to hear from you. What surprised you most about jelly bean manufacturing? Was it the 21-day production time? The flavor layering technique? The fact that some colors come from insects? Drop your thoughts in the comments below. And if you enjoyed this deep dive into industrial candy production, hit that subscribe button. There's a whole world of fascinating factory processes waiting to be explored, and trust me, we are just getting started. See you in the next one.